Hi guys, I am Jayant. Welcome back to my YouTube channel. Today we are going to discuss about angle between two regression lines. Come guys, let's start the video. Don't miss the video till end friends. In this video, we will learn angle between two line of regressions. What are line of regressions? Two line of regressions and the line of regression of x on y and line of regressions y on x. Come, let us start. Guys, here is the introduction for angle between two line of regressions. Forecasting or prediction is a crucial part of human life. We always try to stay ahead of these things that we do. We plan for future, and for doing this, we always look back at how things took place. This is history repeats itself. Although this is a simplified version of concept of mathematical regressions, guys. Regression means going back or taking a step back. Regression analysis is a mathematical way of establishing an average relationship between the independent and dependent variables. We can then use this relationship to predict future results or study past data. Curve of regressions. Mercury is the closest planet to the Sun and the smallest one is the either solar system. The planet name has nothing to do with the liquid metals, since Mercury has named after the Roman messenger god. Despite begins closer to the Sun than Venus, its temperature are not so terribly hot to the planets. Its surface is smaller or similar to that the Earth's moon, which means there are the lot of creators and planets. What are line of regressions? Come, let us see that. If this curve is a straight line, it is a case regression line. The line of the straight line is called as a regression line. That's nothing but the scattered points wherever the closer points are matched with a single line. That line is called regression. Regression line are the lines that the best fit, or so they try to cover the many points from the scatter diagram as possible. And these lines expresses the average relationship between variables. In linear regressions, we find the line of regressions by the concept curve fitting. You know that concept curve fitting, I think it is one of the concept we will use here, and we will use the principle of least square with the curve fitting. Two line of regressions. In this diagram, you can see that x-axis and y-axis are there. Two lines are there. One is line of regression of x and y, and another one is line of regressions y and x. By the method of least square, minimizes the sum of squares of the errors from the specified value. Depending upon which variable are selects as the dependent variable from x and y, there can be two lines of regressions. One is line of regression of x and y, and another one is line of regression of y and x. We use these lines to it's nothing but x and y, the line of regression of x and y. We will use that line to find the value of dependent variable of x for the given value of the independent variable of y. And here the line of regression of y and x, we use this line to find the value of a independent variable of y and the given value of independent variable of x. And we use the least square method to minimize the squares of the errors of the available value of the x from the mean value of y. It's nothing but y bar in the regression of line x and y. And here we use the method of least square to minimize the square of the errors of the variable values of x, and it forms a mean value like x. We will call it as x bar. Formula for line of regressions. The line of regressions of x on y is given by the equation x minus x bar equal to r into sigma x divided by sigma y of y minus y bar. The line of regression of y on x is given by the equation y minus y bar equal to r into sigma y divided by sigma x of x minus x bar. And here is the full form or standard, what are the symbols stands for. X bar is nothing but the mean of x. Y bar is nothing but it is also mean of y. And sigma x is nothing but you know that sigma is called as standard deviation. Sigma x is nothing but standard deviation of a value of x from x bar, from the mean. Here at the same standard deviation of value y from the y bar is given by sigma y. And r, you need to note this, r is a correlation coefficient. It's important. And here you can see that there is one point. Before we have seen one diagram like this, but here you can see that another one point, wherever a line of regression of y on x and line of regression of x on y, both are intersecting each other. At that point, one point is generated, one point is notified, that is called intersection point x bar and y bar. According to these formulas, we can see that both these lines passes through the point x bar and y bar. And this is the point of intersection of these two lines. And the angle between of two lines of a regression, you know that what is a line of regressions, and here we will see what is the angle between the two line of regressions. And the same diagram you have seen previous slide also. Here there will be two lines. One is line of regression x on y and another one is y on x. Both are intersecting each other. Between that you will get some angles like theta. Here you can see that after the point of intersection you will get some theta value. That theta is called as angle between two line of regressions. We have to see that two lines are regression intersection at the point x bar and y bar. Therefore, the correlation that is not perfect. The two lines will be at the angle of theta for each other. Formulas: the line of regression of x and y is given by the equation x minus x bar equal to r into sigma x divided by sigma I of y minus y bar. And the slope of that formula or that line is nothing but you have seen that one line x and y is passing through the another line. That line slope is given by m1. And another one, the equation of y and x is given by y minus y bar equal to sigma y divided by r into sigma x x minus x bar. By this we have got a equation for m1. m1 is nothing but the slope. We are comparing with the standard equation y equal to mx plus c. From that we got m1 equal to sigma y divided by r minus r into sigma x. Similarly, and another equation we got from y on x is y minus y bar equal to r into sigma y divided by sigma x x minus x bar. And the slope of m2 is the slope of that line where the line passes through the x on y. Both are intersecting. No, one line slope is called m1 and another one slope is called m2. Another one line slope is given by m2. When we compare these with the standard line of equations y equal to mx plus c, we will get the equation m2 equal to r into sigma y divided by sigma x. For two intersecting lines with a slope 1 and a slope 2, the angle between these two lines are given by the theta. You can see that here tan theta equal to m1 minus m2 divided by 1 plus m1 m2. m1 and m2 values, we got the values from the previous slide. We will use that equations here. And sigma x divided by sigma y divided by r into sigma x minus r into sigma y divided by sigma x whole divided by 1 plus sigma y divided by r into sigma x into r into sigma y divided by sigma x. And next step, we will take the sigma x and sigma y divided by sigma x common from the numerator. Then we will get 1 by, it will remain 1 by r minus r. And in a numerator, we will just multiply m1 and m2 values. Then we will get 1 plus sigma y square divided by sigma x square. And the next step, sigma y divided by sigma x into 1 minus r square divided by r into sigma square x divided by sigma square y, sigma x square plus sigma y square. And after that, we will get 1 minus r square divided by r into sigma x into sigma y. By multiplying sigma x in a previous, we'll multiply this one to the here. Then we will get sigma x into sigma y divided by sigma x square plus sigma y square. And the final equation we got is theta equal to tan inverse of 1 minus r square divided by r into sigma x into sigma y divided by sigma x square plus sigma y square. And thank you guys. Thank you for watching my video. Please, if you like the video, please like and subscribe the channel, guys. Don't forget to click a bell icon to be updated, guys. Thank you. Thank you, guys.